which means that that gene should be replicated. But it was only possible because these genes wanted to move down and to the right. And that was only possible because of this one, and so on. Which means that we need to be able to make it so that the genes of the reproduced mites are able to be modified.
We've
from
reused
their
some of the same
So
code in order to create
it's not none,
the
but it's not
bias X
everything.
and bias
Now,
Y
you'll see what I mean by
of the reproduced
We go into
mite,
the code,
and
we
it
go
has
into
some of the same
mite
sort of vector
birth
canceling
function.
out properties of that. When a negative comes in contact with a positive, it's able to deviate, but if a positive comes in contact with a positive, then it stays the same, and such is the same for a negative, of that it would stay the same. Now, we ran iterations of this and actually found that the mites are likely to survive 3 times longer whilst having this code in comparative to the mites only having their parents' code in, basically meaning that their bias is exactly identically the same. So what this means is that in specific situations you could have a situation where the mites move down the coordinate plane and just keep moving and don't care about what's in their way. And you can have mites that travel down and then stop and then just kind of chill in an area for a while. You can also have mites that when they reproduce, they just go out in all different directions, doing all sorts of different things. And that is kind of honestly the beauty of randomness, of that certain things are possible and other things are also possible. And yeah. So the movement is an extremely intriguing idea, and the sort of idea of the mutations can be expanded upon. You could make it so that there are mutations that are essentially percentages, and then once it reaches a certain threshold, it will actually augment the behavior um, of a mite. And what that does translated to the real world is the idea of having dominant and recessive genes and how those genes interact with each other, and to see if certain genes that are that are in sort of this dominant state are able to affect more change than those that are in a passive state or a recessive state. But what this does also mean is that when you have a program that is like this, every iteration will be different. You could run the same program 5 different times and get completely different results. Now, some results that I got were kind of disturbing. There was this one result that I got in the sort of last part of the coding that I was doing, where the mites had essentially eaten all the berries. Now, typically the way that this was set up was in such a way where there were berries on the outside that were kind of just around so that afterwards they could reproduce. But in this specific example that I was running, that wasn't the case. They were all kind of meshed together with the mites in this sort of weave. And by doing it in such a way like that, and making it so that there was no sort of way of reproduction, the mites and the berries, for the first time, both died out, making it so that the grid reduced to a 1 by 1 square. That was the first time that I saw that in the 7.5 hours that I had been coding at that point. And it was extremely upsetting, but also interesting at the same time, because it was a real showing of what not taking care of a system and what greed can lead to. This is extremely interesting to just look at also because it means that there are showing of what not taking care of a system and what greed can lead to. This is extremely interesting to just look at also because it means that there are specific setups that you could do that would give you different results. Having the berries meshed with the mites would have a different result than those that would have sort of berries on the outside and mites on the inside, or berries on the inside and mites on the outside, or a sort of cell-like system, or an island-like system, or maybe you have them really far apart. There is no limit to this simulation, except what your imagination is and also what the code says. But essentially, from this point forth, it would just be sort of modifications. Now, someone that is very smart and very insightful said something to me of that this is somewhat of an interpretation of Conway's Game of Life, which I extremely loved that compliment for. And I do somewhat see it now as a sort of take on Conway's Game of Life. Now, Conway's Game of Life, if you don't know what it is one of the most simple zero-player games out there that works at basically the base level because it uses just binary and whatnot, and is extremely elegant. My version is a lot less elegant, but is able to sort of take a lot more creativity to it, and I challenge people to do that. There are specific things that I have done for quality of life also to this, such as making it so that you can pre-program in specific orientations of the mites and berries by putting in a file, and then also making it so that in case your terminal runs out of space, like you're using JGrasp like me, you can have it outputted to a file so that you're able to see it all a lot more clearly. So yeah. So I believe that is all. I'm hoping to do a lot more to expand this, but I do also have a lot of other projects that I am working on. If you have any questions, feel free to leave them in the comments. If enough questions emerge, I may create another video in order to be able to answer those questions and to sort of give an update as to what I've done with this. There is a 3-part full version of the entirety of the process of me creating the program and whatnot, and all of the mistakes and tools that I used along the way. And then there's also a 16 times version where essentially it speeds it through and gets it done in like half hour. It shrinks down 8 hours into a half hour. And it's pretty cool to watch. I definitely turn the volume down on it though, because it's a little hard to listen to. But yeah. As I said before, go check the GitHub. Thank you.